Next, see. If suppose you have a circular ring, the same circular ring you can take. It has charge per unit length as lambda, and you can give it a radius r. Positive charge is distributed here over it, and a small portion of this circle, a small portion of this ring is cut off. Here, a small portion is cut off. Now, this becomes an interesting question, because for a small region, electric field will not be cancelled out, but for all the other regions, it will be cancelled out. So how do we approach this problem? And there is a trick to it. Again, we have our principle of superposition to the rescue. I can write this. I can imagine this ring as a sum of two rings. Easy to say, imagine it difficult. Think of it like this. If this is my origin, so I will find this ring as a sum of two rings. This is the first ring and this is the second ring. In the first ring, what happens is I will have a full ring, that's without any cutout section. There's a cutout section. Cutout section, let us say the cutout section has length dl. So if I have this section with no cutout section, I know the electric field due to this. And instead of the circle, full circle, what I will have here is an element of length, call it dl, but the charge over it is minus lambda. Charge per unit length is minus lambda. Means if I superimpose this negative ring, this is my origin, this is my origin. I take this whole section. I take this whole section and I superimpose over it. It will give me this first thing. I take this region and superimpose over it. The lambda and minus lambda will give you a neutral region, and this is your cutout section. The neutral region is the cutout section. So principle of superposition simply says that electric field will be the sum of the values of electric field due to different cases, because these two cases combine together to give you this case. For this case, electric field was 0. But for this case, you see here it's minus lambda now. Minus lambda, so charge will be minus lambda dl. At this point, electric field will be towards the negative charge. Call it dE. If you write it as dE, the value will be k. Instead of charge, we'll write minus lambda dl upon the radius square, because distance between the point and the charge is r. So that will be minus k lambda dl upon r square. That is the value of E2, charge due to only this small portion. And the resultant value of electric field will be just k lambda dl upon r square. Negative sign means it is in this direction. That is the value of electric field. This was principle of superposition. We are imposing this on this. Here there was plus lambda, here there was minus lambda. And if I could overlap this, Try to be imaginative. If I could overlap this, the lambda and minus lambda, they will overlap each other and give a neutral region. Neutral region is equivalent to the cutout section. These are smart ways to approach problems. Now, any doubts?
So, I mean, you said